Let's start by taking a look at how the demo system I will be using has been configured. The configuration is pretty simple. There are just two nodes connected to a CANBus. The first node is an STM32 development board with a transceiver connecting it to the CANBus. The second device is a Raspberry Pi with an SDC I/O hat providing a CANBus connection. The Raspberry Pi runs as a single-use device when running SDC, as it doesn't have any operating system running. SDC manages all of the hardware on the Pi directly, and that is the case for all SDC implementations. Let's switch to a recording of my PC screen, showing SDC tools together with the video capture from the Raspberry Pi's HDMI output. The Raspberry Pi is running at a resolution of 1024 by 600 here, but you can run it up to full HD resolution. The resolution just depends on what display you are using. The data you're seeing at the moment is coming from SDC's playback mode, which replays a previously recorded data log. To get live data from a real ECU, you need to change the data mode. Here we are just changing the data mode from playback to DBC CANBus so that live data can be received from the STM32. There are two additional configuration sections which are being used, which I've highlighted. These define the DBC files that should be read when the system boots, and they in turn instruct SDC how to interpret the CANBus messages coming from rusEFI. The last thing I'm doing before rebooting is changing the page set to one that is configured for rusEFI values. After that, the device reboots and we'll be receiving data from the STM32, which is already running. We just need to wait for the Wi-Fi to connect. Then we can connect the tools to the Pi and make a few changes to the pages set to show data from rusEFI. The starter page shows some of the configurations required. We've already set these up a few minutes ago. First, let's open a console window and have a look at some of the data items that are available to us. You will see these in the attribute dialog later on. As you can see, there are now some real-time values being displayed. These are being received via the CANBus from the STM32 running the engine management firmware. We can edit some of the gauges that are on the page and change what they are displaying. For example, let's change that RPM value to lambda. Press the ellipsis on the attribute property to see the list of available attributes. The rusEFI ones are namespaced. You will see later on that the Haltech ones, which are coming from the same ECU, are also namespaced. There are a few other settings to change because we are repurposing a gauge instance that was already configured for a different value. The Describe button helps us work out what to set up. We just need to remove the units now that we are not displaying RPM. Units are optional anyway. Time to start up Tuner Studio and have a look at the STM32's data and configuration. Let's change the RPM using the internal trigger stimulator. You will see the tacho change on the Raspberry Pi when I update the RPM value in Tuner Studio. Now we can have a look at the settings we're using for the CANBus. We've got the Haltech and rusEFI broadcasts both enabled at the same time. The broadcast is set to 29-bit, although 11-bit is fine too. And finally, the bus speed is set to 1 megabit. Let's create a new page and have a play around with some of the real-time values coming from the ECU. First, we can take a look at the RPM value, using the value gauge. We'll look at 3 different values. The one that comes from the rusEFI broadcast, the one that comes from the Haltech dash broadcast, and the internal one, which has been mapped, i.e. copied from the Haltech one. The only reason to do that mapping is to make a pager set work that wasn't originally designed for this ECU. Let's add the RPM from Haltech. Here you can see that the configuration is set to copy the Haltech RPM into the internal RPM value. Let's create a gauge to show the internal RPM and then rearrange the display a bit. And we can add a Haltech TPS value for good measure. Let's add some static strings and move things around so that they line up a bit better. Like we did before, we can take a look at the list of attributes exposed by the Haltech DBC file. Only a subset of these will be populated by this particular ECU. Let's pick out a few values and examine them in the console. You don't need to do this, it's just for demo purposes. The values will of course be different between the sources due to both differences in precision and differences in the values over time.